Here is the question. I will describe the question like the main part of the question is like 20 meter depth of the well. So this is the well which is 20 meter and the diameter is 2 meter. So diameter is 2 meter and depth or height is 20 meter. A pump installed. So this is the pump which is installed to empty the well. So the main task of this pump is to empty the whole well. After pumping out half of the water, so this half portion is empty. It means that total is 20 meter. It means this half portion, so this is 10 meter, right? So this is 10 meter. So this half portion empty, and in that time the pump breaks down or the pump is not workable. Another pump installed here, let's say another pump installed here, and the power of the pump is same as the very first one, and the very first one power is given is 5 horsepower. Somewhere here is missing, so let's say 5 horsepower for the first, and the second one also given in the question, so this is also 5 horsepower. First question, calculate the amount of work done by the first pump. So the equation for work done, W equals to mg, and as the very first pump empty half of the water, so in that case the effective height will be h prime is equals to 20 plus this will be not 20, so the effective height h equals to, so it will be 10, and here is 0 over 2, so it will be 5 meter. So for first pump work done is W1, let's say, and this is h prime. So let's plug in the value mg h prime. By the way, we haven't got the m as well, so we have to find out the value of m as well. Indeed, the whole height of the well is obviously 20 meter. Now what we have to do, we have to calculate the volume of the well. So volume is equals to pi r square h prime, actually not h prime, it will be pi r square h, because whole water within the well is h height. So what we have got r, so r is equals to d over 2, so here will be d square by 4 and h. Let's plug in all the value. So after plugged all the value, we have got the volume of the well will be 62.832 meter cube. So this is the volume of the whole water of the well. Indeed, what we have to calculate the mass of the water within the well. So m is equals to rho times the volume, right? So rho of the water is 1000 kg per meter cube, and this is 62.832. So the mass of the water, we have 62 832 kgs. This is actually the total water of the well. But what we have done the half of the water pumped out. So for the very first pump, the M1 will be M over 2. It means we have got 31,416 kgs. Now this value need to be plugged here, right? So this is 31,416 9.8, and the value of H is 5. So altogether the work done for the very first pump is 1.54 times 10 to the power 6 joule, or we could write down 1.54 megajoule. So this is the answer for the very first part of the question. Now the second part, analyze whether it will take the same amount of time for first and the second pump. So what we have to calculate, let's read one more time for the second part of the question, that analyze the same amount of time for first and second pump, their respective portion of the water. So the very first pump pumped the half of the water of the well, and second portion of the water of the well pumped by the second pump, and the power of the second pump same as the first one, which is 5 horsepower, right? So for case 1, let's say case 1, the pump 1, right? So pump 1, the power P in actually, which is 5 horsepower, which is actually 5730 watt, as well as the power of the second pump. So P in for first pump and the P in for second pump same, which is 5 horsepower or 5730 watt, and the work done for very first pump W1, which is 1.54 into 10 to the power 6 joule. And let's consider the time taken by the first pump, that is T1, and for second pump, that is T2, right? So for first pump, P1 is equals to W1 by T. So what we have to calculate, T1 and T2, and we have to analyze that T1 and T2 is equal or not. That we have to calculate, right? So the value of W1 we have got, P1 as well we have got. So T1 is equals to P1 is equals to 1.54 times 10 to the power 6, and P is 57, pardon, this will be 37, I beg your pardon, I made, so this will be actually 3730, actually 5 horsepower means 5 times 746, so it will be 3730. So T1 is equals to 412.87 second, right? Now for P2 is equals to W2 and T2. So we have to calculate T2 is equals to W2 over P2, and P1 and P2 are equal, so it will be 3730 as well for P2. But what is W2? So W2, say now the second pump, let's change the color of the pen. Let's take the red one. So this half portion we have to pump by the second pump, right? Indeed, already we have got the depth here is 10 meter and here is 20 meter, right? So the effective height H2, let's say this is H2, so the effective height for the pump 2 H2 is equals to 20 plus 10 over 2, so it will be 15 meter. Now plug in the value here. So of course the value of W2 is mgh2 over P2. So what is the value of M? This will be actually M2. So the mass of the whole well is 62382 kgs and half is 31416. So M2 will be half as well. So it will be 31416. This is 9.8 and height is 15. The effective height for pump 2 and the power same as 3732. So here the value will be 1238.61 second. So T1 is not equals to T2. So we have analyzed that T1 is not equals to T2, but T2 is greater than T1. So our analyzation have done. So T2 take more time compared to the very first pump, more than like 3 times actually taken. Why? Because the bottom part of the water of the well it have taken by the second pump need more power. It means that more time also required, right? Though the power is same of the pump, so indeed to make the work done more time is required to pump out all the below water of the well. Indeed 3 times more time taken to pump the water. Hope you understand. If there any question, please make a comment on the comment section. I'll answer as soon as possible.